Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss about the working principle of centrifugal pump. So in our last lecture, we have discussed about the turbines and now we'll start about pump. So first we'll try to understand what is the meaning of pump and what is centrifugal pump. Then we'll discuss about the working principle of pump. So pump is a mechanical device, we know that. So you can say pump is a hydraulic machine which converts the mechanical energy into kinetic energy and kinetic energy to hydraulic energy. Okay, so these are the conversions, or we can say that pump is a hydraulic machine which converts mechanical energy into hydraulic energy through kinetic energy also you can take. And this hydraulic energy will be in the form of pressure energy. This will be in the form of, you can say, pressure energy. That is called pump. Okay, now we'll see what is centrifugal pump. Actually, the pumps are variety type of pumps are there. Basically, we'll discuss about only reciprocating pump and centrifugal pump in our this lecture. Not this lecture. In this video lecture, we'll discuss only about the centrifugal pump and reciprocating pump. So today we'll see about the centrifugal pump. So centrifugal pump, actually, this hydraulic energy, we can say, okay, like hydraulic energy, how it is formed from the mechanical energy. So if this mechanical energy if this mechanical energy is converted into pressure energy nothing but that hydraulic energy what I told. So if the mechanical energy is converted into pressure energy with the help of centrifugal force, with the help of or with the meaning of centrifugal force. So the centrifugal force will be act on which way, where with the centrifugal force will act on the fluid. The centrifugal force will act on the fluid. Okay, and that machine is called centrifugal pump. Okay, now see, pump means mechanical to hydraulic or pressure energy, and the same that mechanical energy which which is converted to pressure energy with the means of or with the help of centrifugal force which is acting on the fluid, that is called centrifugal pump. Okay, I hope you understand the definition of centrifugal pump. So this is the model or the diagram of centrifugal pump. We'll discuss one by one in this. So next, what are the components? What are the components are used in this working principle of centrifugal pump? That we'll see here. Okay. So to identify the components, let's come to this picture. We'll see here what are the components are used in the centrifugal pump working. So first one you can see will come from here. Okay, the impeller is the one of the main component of this. Previously we used to call it as runner, so here it is taken as the impeller. So the first one we can consider impeller. Okay, in turbine case, if you have seen, there we used to call it as runner mostly. So here it is impeller, and the second one we can consider casing. Okay, which is the upper part of this, covering part of this. So the next one is casing. Okay, and the third one you can see impeller, casing, then here suction pipe is there. Okay, here suction pipe is there, that one you can write suction pipe. Along with the suction pipe also we can include with the this another one part is there, that is foot valve and strainer, which will be connected to the suction pipe. So we can write suction pipe along with this is foot valve, so that will be connected at the end of this suction pipe, foot valve and strainer is nothing but this will be like it will work like a filter. And the last one, not the last one, we can say delivery pipe also you can consider here. Yeah, delivery pipe. Along with this also we can include some other name, these are the parts or components which is shown in this figure and which is given in the book also. But along with this, we can also include some part like shaft, which is not described but also associated with this. Okay, that I'll tell you where it is connected. And shaft also you can call, and another one also you can say the bearing, which will be connected to the shaft. So here I'll write. Another is bearing is there, which will be connected to the shaft. Along with that also seal will be there. So many equipments are there, like these other things we'll discuss here. Okay. Now, the next one, the principle, working principle, how it is working actually. Now we'll see this one. We'll try to understand how it is working. Then we'll go for one by one part, and even in the working principle also we can able to understand how this each components are working here. Okay, so first one, what is the method? So here we can write working principle or principle, methods of principle we can also say here. This also we can write methods of principle also you can say. So first one, what we need to do, before running the pump, we need to do the priming. So priming is most important, okay, before running the pump, before running the centrifugal pump. So what is the meaning of priming or how to do it? So the priming is very, very simple, which can be done like suppose this is our delivery pipe, this is our suction pipe. So the delivery pipe will be connected at the outlet of this pump will be here. Okay. So before connecting this one in the pump, we have a, like suppose outlet will be there, like only pump part will be there. See, these are the pipes are connected to this, to the pump. Either suction pipe or this delivery pipe will be connected to the pump. So pump will be only a separate machine will be there. So in that, again, in and out will be there. So in the outlet of this, we need to pour water with the help of some mugs or buckets. So you just pour like a quantity of water to that until unless this total part will be filled. Okay, so any kind of air bubbles will be there. Okay, any kind of things will be there in this, so that should be filled and it should be come out from that, and it should be filled of water, so that there will be no chance of pressure difference and there will be no chance of cavitation in that. So to avoid that kind of things, we used to do the priming. So initially we need to do the priming before starting the pump. So that is first one. So next, the second part. The second part, what? Second part is nothing but we need to start the pump. So we need to start the pump in the sense we need to rotate the impeller. So impeller rotation. The impeller rotation is nothing but what I mean to say. If you see this impeller, this is our impeller part. Okay. In this impeller, we have number of buckets or vanes are connected here. These are the vanes what we are seeing. These are the number of buckets or vanes or blades also you can say. These are things are connected in the impeller, and this impeller is connected to this one. Okay, that is nothing but shaft. Okay, and this is called eye of the pump. So the diagram what we are seeing here, actually here itself I will explain the working principle of all each components also. Okay, now this is as the suction pipe you are seeing here. So actually the suction pipe is connected to this pump. If you see, like pump will be there, this is the pipe, and here suppose a pump is there, actually it will be connected like this. Then from here this will be outlet of this. This is the inlet or input like suction pipe, and this will be the delivery pipe. So it will be connected to this one like this. So water will be come from here and it will be directly strike on this center, but it is given in this view so that it is given dotted line, and you need to assume that it's like this, working like this. Okay, so the next step is impeller rotation. Impeller rotation in the sense how it is going to rotate. Now this will be connected to the shaft as I told you, and this shaft is connected to the electronic device. So with the help of electricity, we can run the impeller. Now, when the impeller started running, okay, how it is running? Because it is connected to the shaft. Once you switch on the electric switch, so the shaft will be started running, the motor will be started running. With the help of this, we can say this pump also started running. Now, yeah, So once it started running, actually, what will happen? It will create, the next step will be what? Okay, once the impeller started and impeller started rotating, then we have a low pressure created. We have a low pressure creation at that point at impeller. That is the next step actually. So I hope you understand, like when it started running, so at this point we have a low pressure created. Okay, so because it started running with a high speed, okay, so that here at this point low pressure will be created in that. So we can say that near to the eye of the pump, a vacuum is created. Okay, so low pressure at impeller will be created here. Now, due to the low pressure here, obviously like means that fluid transformation, or we can say the fluid movement will be started where the high pressure liquid will be there. So high pressure liquid in the sense more pressure of liquid. So at this point, if you see, this is our sump level. This is our sump level. Like you can say, suppose it is a river or it is a pond or it kind of such kind of water contents or liquid contents, wherever it can be. I'm talking about the water. It may be a chemical industry, it may be a other industry, power plant industry, it can be some other industry where this applications. So the liquid will be started moving. Suppose this is our, these all the things are P atmospheric. That means atmospheric pressure is there. Okay. So from this atmospheric pressure, it started like this is our high pressure will be there. Okay. So from this high pressure liquid, the water or the liquid, it started sucking out through the suction pipe. That's why it is called suction process is started here from this, and through the pipe which is connected, that is called suction pipe. Through this the liquid will started moving up here. So once it goes up, it is going to strike here at the center. Then after striking here, these valves are there, so this is backward valve actually. Okay, here we have taken backward well or valve, or not valve, you can say that is blade, backward blades. That blade actually, let me tell you here, the blade which is connected, that is backward curved vein or backward curved blade also you can say. So that is going to strike here. Though it started rotating, so it will be like, you know, when it is started moving or rotating, so water will be sprinkled here. Like see, it struck here, then it started the direction. You can see the directions is given already in the arrow mark here. So the water started sprinkling here and it is going out from the center to out. So this centrifugal force acting on that, and the water will be come out from here and it will go like this. You can say it will go out from here. So that is the procedure of water is moving to the outwards. That's why I've told you the centrifugal force acting on this. So in the impeller also, as I told you, a number of blades are connected to this one, and which is mounted on the shaft. So this is the low pressure created, and the water started sucking from here to high pressure. The next one is low pressure and fluid movement. We can say fluid movement from high pressure to low pressure. Okay, and the next one what, that once the fluids came, then there is a increment of velocity and pressure. So now high pressure liquid came, so here also like velocity and pressure both will be increased here. Now we'll go for the increment of this one. Then after that, conversion of velocity like to pressure, that I'll tell you. Okay, these are the process are there, and then after that, that high pressure fluid will be come out from there. Like how it will function, I'll tell you. Now when the liquid came here, now you can see it is going out. These are the casings. So casing actually it is used in the centrifugal pump. Mostly reaction turbine we have seen that one. Okay, so though it is a tight air passage which is surrounded in the impeller casing part. I'm talking about the second one. First one what I told about the impeller, I hope you understand. Second one is casing. So casing is nothing but, casing is variety type of casings are there. Okay, we have like this one casing, you can see increase in, if you see here, increase in diameter or increase in area. So increase in area, in the sense, we know one equation, continuity equation. We have discussed about the continuity equation. What is the continuity equation? The continuity equation says that A into V equal to constant, or we can say A1 V1 equal to A2 V2, that we have seen. So here what is the meaning? The area, if is increasing, then velocity is going to decrease. If velocity increasing, area will be less. So here also same thing. If you see here, area is very less. So area very less means velocity will be more. Okay. And one more principle will be there. That is one thing. Then what will happen simultaneously? If you see, the area of this casing is increasing manner. So area of this increasing manner means our velocity is going to decrease here. Correct. Velocity is going to decrease here. Now another one principle I'll tell you, that is Bernoulli's equation. In the Bernoulli's equation, if you remember, we have like pressure energy, and next is kinetic energy, okay, plus potential energy. Potential energy is equal to constant. So there we have seen, now potential energy is nothing but the distance. If you see, this is the center line of this. Now the distance from this sump level to this one, if you see, this is the center line, okay, and this is the sump level. So the height of the suction pipe, or this height, is constant. So the potential energy is fixed here. Okay, we can cancel. Now what are the remaining? Pressure energy and kinetic energy. Now here we are seeing here that velocity decreased. So velocity decreased is nothing but kinetic energy also decreased. If kinetic energy decreased, then obviously this pressure energy is going to increase. I hope you understand. Okay. So here kinetic energy, velocity decrease in the sense, because velocity, kinetic energy, we know that half mv square. So velocity decrease means our kinetic energy decrease. So that here, if you see, the pressure head increased here, or the pressure energy increased here. Which point? At the delivery pipe point, we can say. So the delivery pipe, one more terminology I'm talking about, this one. Okay, casing after that delivery pipe. Okay, okay, one more point also I told you that casing are variety type of casing. This is one type of casing is there. Another type casing is like volute casing. Just to keep in mind, different kind of casings are there. Volute casing, and this is our actually volute casing, this one, which is connected here. And next is vertex casing. Vertex casing. Another one is casing with guide blades. Like in the casing will be fixed. That will be fixed with guide blades. That is one more type is there. Okay. That is one more type, casing with guide blades, and vertex casing and volute casing. So volute casing we have used here. This is volute casing which is used. Vertex casing is another type is there. Okay. And now the delivery pipe. So delivery pipe, which, and here delivery pipe, this where you can see, this is the delivery pipe, and this portion is given actually, this is a very long, and to show in the short manner, there is a cut portion is given, so that we need to understand this is very lengthy pipe, but when showcasing, we used to give a cut portion here, so that we can understand it is a lengthy pipe. And the valve, this delivery valve is connected to this one to control the flow. Okay, I hope you understand. This is the delivery pipe. Suction pipe, already I told you, suction pipe with foot valve and strainer. Okay, so this is the suction pipe, and here the foot valve and strainer is connected only to filter out the dust particles and some kind of leaves and papers and sticks. So many things will be there in the water, so that need to be strained out. That is used. And the shaft, already told you, shaft will be connected at the middle of this, and this is the bearing part will be there, which is connected to the shaft. Okay, so these are the components, and the working principle, as I told you, that this is the working principle methods. Any other thing is left here? Yeah, mostly we have covered it. Okay, and the next one I'll show you. These are the two different types of, one I told you, vertex casing, another one is casing with guide blades. Vertex casing we can see like this. This is the vertex chamber, impeller will be there, and here the guide blades are fixed with the casing. So these are the types of casings are there. Next we will just have a discussion about the advantages of this. Advantages of this centrifugal pump. So for the very simple things we can write, this is simple in design, we can say, or simple in construction. This is one point. Simple in construction. Second one, we can get a smooth flow. We can get a smooth flow or continuous. So smooth flow with continuous flow will be there. And here the maintenance cost will be low. Low maintenance cost, or low cost we can say. Low cost of maintenance and low cost of initial investment also we can say. Okay, low maintenance cost. The next one is, and it is suitable, this one we can say it is suitable for large discharge or large flow rate or high flow rate we can say. Large discharge or high flow rate. And some disadvantages will be also there along with that. That also I'll highlight this. Some things we can write in your exam paper. Yeah, this will be not suitable. One thing, this will be not suitable for high viscous fluids. This is not suitable for high viscous fluids. Okay, this is one disadvantage actually. And second one, I told you already, priming. So always we need to do the priming. Priming need to do at starting always. Okay, and sometimes it will be very less efficient for the we can say less efficient at low flow rate. At low flow rate. For the high flow rate, it is very suitable, as I told you, but for the low flow rate, it will be less efficient. That means efficiency will be not that much good. So these are some disadvantages are there. Along with that, I will tell you some applications of this. So applications are very simple. We can use the applications in a household also, you can see. So first one I'll write the household applications. Second one we can write like water supply. Wherever you can see some water supply cultivation fields also. Cultivation fields. Second one or third one I can write HVAC. Heating, ventilation, air conditioning also we can use. And power plant also we can use. Power plant. Then we can write some chemical industry also we can use, or chemical plant. And many more applications are actually there. A lot of applications are there. Just I've given some few applications and few advantages and disadvantages. And these are the working principle of centrifugal pump. I hope you understand. Maybe I have missed some points. If it is there, you can give a comment or query. If you are having any kind of query regarding this, you can give a comment. Actually, this is the total height, the head, total head of this, and here it is the delivery head, like up from this center point at what level it is water is supplying, and this is the suction head, like from which point the water is sucking and it is coming to the center point. So the total head can be written HD plus HS. So like that, many more points are there. If I think I have missed anything, so you can give a comment that I can address to you in that also. I hope you understand this lecture. If you are having any kind of query and doubt regarding this, you can give a comment in the comment box. Thank you all.